Here are 3 Ryobi Lithium Plus HP batteries. Now there's lots of good information out there about how to work on older Ryobi lithium batteries, how to replace cells, replace boards, perform PCB resets, etc. But I haven't found very much on these specifically, the Lithium Plus HP line. The way that you can identify these is with the extra 2 contacts that are on the back of the battery. All of the Lithium Plus HPs have those extra contacts. So on the bench, I've got a P195, a P191, and those are both 3 amp hour, but different sizes. I'll come back to that later. And then I've got a P193, and that's a 6 amp hour battery. So why are there 2 different 3 amp hour batteries that are different sizes? Let me hold them up next to each other. The 195 is about kind of like a 1.5 height, while the P191 is kind of the double height that you've seen in previous battery packs. In fact, that double height, P191, is basically the same height as this older 4 amp hour battery. This is a P108. So why is the P191 and P108 the same physical size, but obviously one is 4 amp hour, one is 3 amp hour? It would seem like this is a lower capacity battery, and it is in terms of total amp hour capacity, but I believe what's different is that this can put out more current, while this 4 amp hour battery has more capacity at lower current. You'll notice this one subtly is Lithium Plus. This one's Lithium Plus HP. The HP basically means more current for tools that can use them. So how are they accomplishing this? Both of these batteries have 10 cells inside. So they have an arrangement of 5s2p, that's 5 groups of cells, and each group has 2 cells stacked top and bottom. What they're doing here is they're using 1500 milliamp hour cells. When you use those 1500 milliamp hour cells, you can get much higher discharge. We're talking minimum 20 amps per cell, so potentially 40 amps with the 2 in parallel. Really high discharge, but at the expense of total capacity. So here we're using 1500 milliamp cells, whereas on these older batteries, the 4 amp hour, they're pairing up 2000 milliamp hour cells. So that's how they're ending up with more capacity, although this one would be capable of delivering less current at any given time. So then the next question is, all right, so they've got a 3000 milliamp Lithium Plus HP. Why is there a tall one and also this sort of like mid-size one? They're the same size in terms of this shape, but obviously the P195 is shorter. How are they doing that? Well, with the P195, they actually switched to a new cell form factor inside. This has the new 21700 cell instead of the older familiar 18650 cells. So instead of being 2 in parallel, this is actually just 5 cells in series. They're larger cells with a capacity of 3000 milliamp hour each, but just 5 cells in series, no paralleling. So they're actually able to get the same amount of power and both supply the HP levels of current, but in a smaller form factor. So next, let's open these up and I'll show you what's inside. Going back to Ryobi's earliest lithium batteries, the way you open them up was by removing a single screw off of the stem here, and then 4 screws from the top. Usually one of these would have a little cap on it that you had to remove first, but it's 5 screws accessed from the top. And all the batteries I've seen before the Lithium Plus HP line. On these, you still have the single screw on the stem, but then there's 4 screws accessed from the bottom and no cap that you have to remove. So that's the only difference. Let's go ahead and open these up. And yes, I'm using a Milwaukee screw gun to open up Ryobi batteries. Here are the battery cases on their sides, and I find it interesting. The P108 is the classic 5s2p, and they're 18650 cells. The P191 3 amp hour is exactly the same, 5s2p 18650s. We already talked about the reason for the difference between their capacities. And then the P195 3 amp hour, sure enough, has 5 cells in a row. They're staggered vertically to make those bigger 21700s fit in the overall length that's needed, but that all makes sense. But then you get to the P193, and this is really odd because initially I would have assumed there'd be 3 cells in parallel for 5s3p. 2000 milliamp hour times 3, that would be 6000 milliamp hour, 6 amp hour. But that's not the case. There's only 2p. So I assumed, well, it must be 2 of these big 21700 cells. That would also make sense because these are 3000 milliamp hour. 2 times 3000 milliamp hour would get you to the right place. However, these are definitely not 21700s. If you measure the width on here, it's like 67 millimeters. So these are definitely 18650s. That 650 means 65 millimeter length. So something odd happened here. It's almost as if Ryobi engineered this to take 21700s and then went, oh, hey, we can just put 18650s in after all. Pretty odd that it has nearly the same cell configuration as a battery that has half of its capacity. So now I'll show some of the similarities and differences between these boards. So starting with the P108, this is probably the most common board that I've seen inside of Ryobi lithium batteries, this or something very similar to it. And what's notable first is that it has this data header on the front. It looks like clock, data, ground, 4.4 volts, and reset. So that would be the header for programming the microprocessor, or potentially the factory, or engineers could use that to monitor what's going on. The other thing visually you can see is this big heavy tab which connects to battery pack positive and connects it to the board through this heavy soldered tab on the edge of the board right here. Lastly, no HP contacts on the back. So that's the P108 sort of classic style board that I've seen on lots of Ryobi batteries. The 195 and 193 have almost identical boards. Actually, I don't want to say identical, but I have not been able to find any differences between them whatsoever. So I'll show you, I'll go ahead and use the P191 to show you what it looks like. Notably, there's no data header up here like we saw before. Also notable is this red wire. This heavy red wire connects to this contact on the front of the board. It's actually not on the board. It's connecting to a strip which passes through the board and provides positive power from the positive end of the battery through this red wire on up to the contact on the stem that powers the tool. Meanwhile, this strip also allows the positive end of the battery to connect to the board. So there's a connection to the board there and a connection to actually pass power to the tool there. Has the HP contacts in the back, of course. One more thing that's fairly interesting. Down here you'll see a label that says P191, 192, 193, 194, 195. So apparently this is the board that can work on any of those 5 lithium plus HP batteries. Compare that to the 6 amp hour P193. It's almost identical, but here again, it looks almost like a data header is up here. And this label, strangely enough, it omits P192. It has all the others, but maybe P192 wasn't available yet at the time this board was made. I'm not sure, but it is strange that it omits the P192 4 amp hour version of this battery. So that gets to the reason for why I'm creating this video. You'll see these lights flashing back and forth on the 6 amp hour battery. At some point, maybe it got wet, I'm not sure, but it started doing that, and it wouldn't show state of charge when I press the button. It won't charge on a charger, it won't power a tool if you plug it in. And that's what started me down this path of learning as much as I could about these and searching for a solution to how to fix this. Now there's lots of videos out there, good Reddit posts about how to reset these older style boards like this one on the P108, basically shorting 2 pins together and that giving the PCB a reset. I couldn't find anything on these Lithium Plus HP boards, or else the information I did find just didn't match what I was looking at. So I had to kind of look into it and figure it out myself, and here's what I found. This one looks like it has a data header up here, but actually I don't think that's what that is, or maybe it's redundant. I think the data connection is through these 6 pads here. I think the pads and the surrounding holes in the PCB are designed to work with what's called a J-Link debugging connector. It has spring-loaded pogo pins that allow connecting to the microcontroller on the board for burning firmware and debugging, but without having to have a permanent socket on the board. So I looked up that connector, figured out the connections, and I figured out that these 2 pads are ground and reset. So shorting those 2 pads together is what resets this style PCB. Now this board is bad, so it won't demonstrate very well, but I'll demonstrate with this good board what that looks like. So normally you press the state of charge button, you get the state of charge showing there. And now if I were to short those 2 together, I like to use a resistor just because it prevents me from accidentally touching any of the other number of things on this board and accidentally sending full current to it. This happens to be a 220 ohm resistor, but probably any value would work. And I just drag these 2, or I drag the pins across these 2 contacts. And when I do that, you see the lights light up and then they go dark again. I can press the state of charge and it shows me state of charge again. So it's really just a matter of shorting these 2 contacts together to reset the PCB. Now you can do that with a screwdriver or a wire, whatever you want. You don't have to use a resistor, but call me paranoid. That's the way I like to do it. Meanwhile, on this 6 amp hour battery, no such luck. I can press the two, I can touch those two contacts together, and it does do some sort of reset, but then it goes to flashing the single light over here, and I don't ever get a state of charge. If I press the button, nothing happens. Eventually it will start flashing left to right. And at this point, I've opted just to go ahead and swap out this board. So that's why I have this battery, this P191. I bought this used. This has bad cells, but presumably a good board. Meanwhile, my 6 amp hour battery, I have tested it to show that it does have really good batteries, but the board is bad. So the next step I'm going to take is to desolder this board and swap it on to this one. I've already desoldered this one, and I'll show you how I do that and show you how I swap them, and then we'll reset the PCB and hopefully it'll come back to life. And just to note, the situation you might get into where you need to reset the PCB is when one of these cells or cell groups falls below some threshold voltage. I don't know what it is exactly, probably around 2.5 volts. And that would also happen, of course, if you remove the board from the battery pack, if you're swapping boards, that sort of thing. So anytime you have a cell or cell group that falls below the threshold voltage, you would first need to charge the cells and then perform a PCB reset. And that's what you can see I did on this one back in April, refurb PCB reset plus balance. All right, it's time to desolder the board off of this P191 3 amp hour donor battery. Got solder wick, some solder to alloy the factory lead-free solder with, and some flux if needed. I want to take some of that conformal coating off of here, and then I'm going to desolder this big wire out of here. Let's add some of our own solder to soften it up or lower the temperature. Oh yeah, it's definitely going to be a big heat sink. I've got a pair of tweezers here to help me pull it out once it does melt. Here we go. Oh, almost there, almost there. There we go. So we're free. There's the main wire. Now let's turn it around. Let's start on the negative end here. This is kind of the next heaviest solder joint that I'll have to deal with. So again, I'm just gonna scrape some of that conformal coating off of it. Ooh, it's hot up there. Don't want to grab the joint you just desoldered. First step, alloy some of my lead/tin alloy with the existing lead-free. That'll lower the temperature. That'll allow it to actually melt all at once. This is a big old piece of metal that have to heat up basically the pad going down to the battery, as well as the pad going across the PCB, as well as probably half the PCB, given that this is the ground. So I have to heat up quite a bit all at once. And then foolish me, I forgot to unscrew the PCB, so it's not going anywhere even if I get the solder joint loose. But let's give it some solder wick. Big solder wick for taking lots of solder. And this is pre-flux solder wick. You can see it flowing out of the joint and into the solder wick. Desoldering actually gets harder as you get more and more of the solder off, because you have less and less ability to make contact with the joint. When it's a big old blob, your soldering iron can touch large parts of it and conduct a lot more heat. We'll deal with what's left, these slight solder connections next. Let's actually unscrew the board from the battery case. All right, so what I figured out is the tabs that go down to measure the individual cell voltages, these are flexi. So all I need to do is disconnect this big heavy negative one. I can tip the board up, get it off of there, and then work on these one by one. May have been the wrong move to pull so much off, because now I can't melt it. Oh, no, it's glued down here. Oh, sneaky. So that's something I haven't seen before. It's actually glued down below, or maybe that's just that conformal coating. I don't know if that was intentional or not, but it's definitely sticking it to the bottom of the case here. So no problem, I was able to break that pretty easily. All right, so now it's free, and now it's just waiting to be freed from this tab by the small amounts of solder that are left. There we go. Here's the next tab that's holding things in place. I'm just gonna heat the tab instead of the place where it meets the board. Okay, that's pretty much free. All right, heat the next tab. Let it heat transfer up through the joint to the board. There we go. Okay, and next one, melt through the board. There we go. Just two more now. Come on, there we go. And the last one, this is the positive, the most positive connection from the front battery to the board. I'm gonna see if I can get through the conformal coating. Yeah, I rushed it. I should have cleaned this off first. Come on, tab. Drop out. Ah, it was this thing. It was the connector for the big cable was mechanically still stuck and holding on there. So board is free. We survived that and we succeeded victoriously. So here's the old battery case. Not going to use that. I might harvest some cells out to see if they can be repaired, but I don't have high hopes. All right, so next I do want to do some detail cleanup on this board that'll make it easier to install on the other pack. I'm going to use a brass brush with proper amount of force to clean off that coating. Didn't want to do this before because I'd be touching a bunch of metal contacts together, and even though the battery was mostly dead, well, still had a little charge in it, and I didn't want to ruin this board. So there's how I'm going to get off extra conformal coating. I am being gentle, it just doesn't really look like it. I actually want to look at what's going on in the underneath. Let's see if I can't soak up some of this solder on the bottom. Yeah, there we go. Let's clean up this slot. Starting by alloy. Okay, alloyed. And suck it up. Buttercup. Oh yeah, this is looking good. Another way to do this would be with a solder sucker, which I also have. That actually works pretty well as another option, but I kind of like using the wick. Lots of coating on this one. Guess we won't be as waterproof when we're done, but that's okay. So now we just give it a wipe with some isopropyl alcohol, and I'll return when it's all cleaned. So I found my first difference between the two boards. Here's the P193 and the one I just took off of the P191. The difference is in their MOSFETs. So these are what turn on charging and then turn on discharge to the power tool. Obviously the P193 had 2 per side and the P191 just has 1 per side. I checked and they are the same MOSFETs. I don't know if you can see that, but they're the IRFB7437. It's literally just a matter of having them doubled up on the 6 amp hour. So I think I am going to do a MOSFET swap. I think I'll just be basically pulling out these screws, desolder the whole block, and then swap them over. So here we go. All right, so the FET block is held on just by the MOSFET pins. Now I can pull these out one at a time. Number 1, number 2, number 3, 4. Darn it, I can almost get these in place, but you can see that they actually sit up higher on this original block. So, all right, I'm gonna use the original block, original FETs, transfer everything over, that way there's no doubt. So I actually need to take off the existing FETs that are on this thing. Okay, there's one of the shorties. Second shorty. Now, let's pull out whatever solder we can. All right, let's put the tall block onto here. Okay, so I've installed the big aluminum piece from the 193 onto the P191 board. So now I just need to poke the original 193 MOSFETs through the holes, mount them to this plate, solder them into the slots. We'll see how easy that is. Okay, FETs are tightened to the heatsink. Heatsink's tightened to the board. Now we just need to solder the FETs to the board. Easy. Probably easiest from this side. Okay, I've got all 4 MOSFETs transferred over from the board that started on the P193 over to this donor board from the P191. It probably would have been fine with just the 2 MOSFETs that were on it, but I didn't want to take any chances, so I transferred them all the way over for full capacity. So now I need to put it onto the original battery pack, and it's just a matter of slipping it over all of these little connectors, and kind of tricky, so I just start with the front and work backwards. And I think I need a tool here. So yeah, I just basically try to put each battery tab in one by one. Okay, there's 3, and I see a light flashing already. Oops. There's 3, let's get number 4 in. There's 4, 5, oh, there we go. And there's 6, if I'm not mistaken. I just have to do a little adjustment with this one here. There we go. That's it. All right, so yeah, maybe a little bit of fiddling just to, hey, there we go. And we're showing 2 lights on the fuel gauge, which is correct for this battery, which is at about 3.6 volts. So we'll press the button again. 2 lights matches 3.6 volts. Hey, that's probably gonna be a win then. I'm just gonna solder this all together, put the screws in, put the cap back on, try it in a tool, try it in a charger. That'll be the final test to make sure it's all good. But so far, things are looking up. Oh, careful there, bud. Now I'm just reattaching the battery thermistor. This comes off the PCB and snakes down the side of the cell case and just rests on top of the negative battery connections towards the back on the left-hand side. The thermistor is a simple device that takes a temperature from the batteries, turns it into a voltage that the PCB can read in order to detect if there may be an overheating condition. So it's pretty important to go ahead and put it back. Reassembly of the P193 is really just the opposite of the disassembly, so I won't go into every step, but the side paddle buttons that release the battery from the tool, they are a little bit different from any other battery I've seen. So that was the only tricky part about reassembly here, but mainly it's just like any other battery. You take the battery case and PCB and slide it into the main housing, reinsert the latches on the sides, screw down the top. First test, will it charge? Flashing red, which is normal for testing the battery, and we're flashing green, which is normal for charging. There's the good news right there. The state of charge light is flashing at the same time as the charge light on the charger. That usually means things are all good. The next test is, will it power a tool? No problem. A little knowledge goes a long way when it comes to keeping these power tool batteries alive and out of the landfill. I'm sure appreciative of all the help I've received online, and I hope that this was helpful to someone out there that may have a problem with their Lithium Plus HP battery. If this was helpful to you or you just enjoyed the video, I'd appreciate the like, but in any case, thanks for watching.